Today we're going to continue talking about volumes, specifically cylindrical shells. Now, in theory at least, there are no problems on the AP exams where you would be required to use cylindrical shells. That said, every now and then there's one where it's like, yeah, you can do that with um, an annulus or something, but sometimes it's easier to do cylindrical shells. So I'm going to go ahead and teach it to you that, and it's something that I think that someone who, at least in theory, if you guys do well enough on the AP exam, you might be going straight into third semester calculus, which would mean that they're going to expect that you have seen some of the things that like this. So anyway, the idea is that here when you do a cross section, instead of your cross section being perpendicular to your axis of revolution, that your cross section is parallel to the axis of revolution. And because it's parallel, it doesn't sweep out an annulus. It actually sweeps out sort of like the walls, not the top and the bottom, but the walls of a can, right? A soda can or just, a vegetable can that's been emptied out or whatever. It sweeps out that part. And because of that, the area of that is 2 pi r times the height, right? Remember, that's the formula for the lateral area of a cylinder. Do you remember that from way, 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 way back? So basically the idea is this. If you have a hollow cylinder like this, and you want to know the area of this outside piece, well, that's going to be equal to, if I unfold it, this was the circumference of the base, and this is the height of the cylinder. And that's why it's 2 pi r times h. Okay, now this example will show you one where it's like, yeah, I can see why that would be. We'll talk about why it's better to use shells on this than it is to use something else. So the region bounded by the curves, y equals 4 minus x squared, and y is equal to 3x, is revolved about the line x equals 2 to form a solid. Find the volume of the solid. All right, since they didn't give me where to start and where to end, I am going to do two things. I'm going to sketch it, and I'm also going to find where do these two things intersect. Okay, I'll find the intersection first. It doesn't really matter which you do first, but I'll do the intersection first. So I'm going to have 4 minus x squared is equal to 3x, which means that 0 is equal to x squared plus 3x plus 4. Excuse me, minus 4. It's like something's got to be wrong there. I was pretty sure this was one we had set up so that it would factor. So 0 is x plus 4 times x minus 1. So x equals 1 and x equals negative 4 are where these two intersect one another. So let's draw a quick picture of that. We need a lot of room over on the left, unusually. At x is 1, y is going to be 3 for both of these. And when x is negative 4, y is going to be negative 12. So somewhere over here. And connecting those actually gets us the line y equals 3x. And then the parabola goes up a little higher, has its vertex at 0, 4. But it looks something like this. To me, that always looks sort of like a surface of a wing. Okay, I don't know if I've ever told you, originally I was studying aerospace engineering. And so we did a whole bunch of stuff like this. And it's like, yeah, that looks like one of those where you would have multiple slices through the wing and you had to do stuff with it. Anyway, so we're going to revolve this around the line x equals 2. Now, x equals 2 is this vertical line over here. And the reason why it's easier to do shells on this is because if we were to slice perpendicular to our axis of revolution, in other words, change everything into terms of y, which isn't terrible to do. Change everything to be x in terms of y, which isn't awful. But notice that if it's to slice right here, I'm going to draw this, and then don't worry about drawing that. Notice I'm going between the parabola and the parabola. So that means I've got to think about the two different branches of the parabola. It's not terrible. It's doable. But then when you get down here, you're going between the parabola and the line. So instead of two curves, you've got three different curves you're really thinking about. You're thinking about this side of the parabola, this side of the parabola, and the line as three different curves. So it's actually simpler if what we do is slice parallel to the axis of revolution. If we slice like this. When we slice like that, I'm going to move this 1, 3, make it a bit smaller. Well, I'm just going to put that's at y is 3. That'll work. So when I revolve this around, the part that I would see in the xy plane, I would see it again when it gets all the way around over here. And on these, I will sometimes go ahead and draw the rest of the three-dimensional object. It looks sort of like this. Right? It's just the outer wall of this cylinder. Let's do the height of the cylinder first. So anyway, like we've been doing, we would write, well, what's the area when I revolve that around? Well, it's the outside of a cylinder. So it's 2 times pi times the radius times the height. And I'd like to rewrite that so that it's in terms of a variable, x, for wherever my slice happens to be. Because where I slice it, you can see that when I'm over here further towards where these two intersect, the height is going to be much less. The height changes, and then the height gets bigger, and then the height gets smaller over here. Likewise, the further I move to the left with my slice, the further it is away from the line x equals 2, and so the radius gets bigger. Okay? So it's going to be 2 times pi. Now, this is the one part that's a little bit different. You're like, okay, so how am I supposed to give the radius? Well, the radius will be this distance right here. That's going to be the radius. And this is going to be the height. The height is usually the easier part. The radius is usually the harder part. What expression can I give for this radius? Well, it's not immediately obvious, but I selected just a random x value at which to put my slice, right? So the coordinates of this point and this point are both x something. This would be x comma 4 minus x squared, and this is going to be x comma 3x, right? So this horizontal distance is just the difference between the x value here, which is 2, and the x value here, which is whatever x happens to be. So the radius is going to be 2 minus x. And notice that when we're going from side to side, we're always going to be doing what's further right minus what's further left. Otherwise, I would get a negative sign. So if the axis of revolution had been over here, it would have been x minus wherever my axis of revolution was. Okay? And then the height is the distance from here to here. So that is the difference in the y-coordinates. Well, the y-coordinate up here is 4 minus x squared minus the y-coordinate here is 3x. So then the volume will be, I'll factor out the 2 pi times the integral. Everything's in terms of x, so my limits of integration will be in terms of x also. So this will be from -4 to 1. And if I really want to do this by hand, and we will because we have lots of time today, we're just doing this, I'll need to distribute and gather up the like terms just so I can take the antiderivative easily. So the highest power is going to be x cubed. I'm going to have a negative x squared times a negative x, a negative x times a negative x squared. So that's going to be positive x cubed. I'll also have a negative 2x squared and a positive 3x squared. So that's going to be plus x squared. For x terms, I'll have a negative 4x and a negative 6x, so that's negative 10x. And for my constant term, we will have 8, all dx. If it's something where you're putting it into a calculator, I wouldn't bother with that. I would just put it in exactly the way that it looks. There's no point in doing this. The only thing that can happen is, the only thing that can change anything is that you could accidentally mismultiply and now you've lost some points. So let's see, this is going to be 2 pi times 1/4 x to the 4th plus 1/3 x cubed minus 5x squared plus 8x, all from -4 to 1. So that's going to be 2 pi times, let's see, we'll have 1/4 plus 1/3 minus 5 plus 8, all minus, let's see, that's going to be a positive times 1/4, that's going to be that'll be 64, right? My mind suddenly went blank. Minus 64 thirds minus 80 minus 32. Whenever I have something like this, so if this is on the free response part of the AP exam, right, put your pencil down, walk away. If you're taking a class, they're probably going to expect that you simplify this. And so to simplify, I always think about the whole numbers, I get them together, and I get the fractions together with a common denominator. So I've got a positive 1/3 plus 64 thirds, so that's 65 thirds, which is really horrible because that doesn't come out to be anything nice. And I've got a 1/4, and then let's see, with whole numbers, this is going to give me 3 And that's going to be 52, so that's plus 55. So that is 30, 21 and 2/3. Oh, this is just awful, isn't it? Right? You can see it's not one where somebody has taken the time and looked ahead and gone, oh, we're going to make this come out to be something really nice, and we're going to spend hours making a single good problem. It's just kind of ugly, but we'll go ahead anyway. So that's going to be 21 and 2/3 plus 1/4 plus 55. So that's 2 pi times 76. 2/3 plus 1/4 is 11/12. So that's going to be 142 and 11/6 pi. That's just awful. And now I'm curious if that's even right. So I'll grab my calculator and wake it up and say, hey, do this for me. First, I'm going to figure out what is 142 and 11/6 times pi. $451.866. And then let's see, 2 pi times the integral from -4 to 1 of 2 minus x times the quantity 4 minus x squared minus 3x. With respect to the variable x. Uh-oh. That's not close. I've made at least one egregious error. I got 104.772. It's a good thing that I'm putting this on a platform where no one can see it. Oh, wait a minute. Well, let's check each step of the way. So did I miss multiply? Yeah, you guys could look for my mistake too. Like, no, it's more entertaining to watch Mr. Davis just sit and try and figure this out. Having trouble typing today. minus 10x plus 8. With respect to x. So that's wrong also, apparently. Oh, hang on. Dun, 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 dun. Okay. 316.777. I saw the mistake. The 400, whatever, the 104, I had a mistake. I saw where I typed something wrong. So 1/4 x to the 4th, 1/3 x cubed minus 5x squared plus 8x. 1 plus a third. Let's see. 2 pi times 1/4 plus a third minus 5 plus 8 minus 64 minus 64 thirds minus 80 minus 32. Yeah, there's something wrong there. Because that's where you get 450 something. 1/4 plus a third minus 5 plus 8. One-fourth of 256 is 64. 4 cubed is 64, and that'll be negative. That's 16 times 5. I don't know. Somewhere something went wrong. The correct answer is 316.777. I do not know why. Bonus points for finding my mistake. That's what I should do. All right. So your assignment is, I think, to finish the volumes worksheet.